So I had some questions about some of the homework problems from yesterday, problem 3, 5, and 6 especially. And there was a piece of information I may have misled you on for problem number 6 that we'll fix. But I did want to just show you the setup for those problems, just so you had them and make sure we're on the same page, okay? So problem number 3, anytime they are talking about the speed of travel, and you have like an airplane where the wind is either it's called a tailwind when it's helping you travel a little faster, or if it's pushing against you and it would slow you down. So here they gave us information about the speed. So the higher speed would be when the wind was helping you, so you're going to add that wind on. The lower speed is when that wind is pushing against you, so you have to take that wind into account and take it away. That's why oftentimes if you travel your flight, one direction may be faster than going the opposite direction. There's some other things in play, but that can happen, okay? For number 5, I was thinking about the fact that if I have the number with A in the 10 spot and B in the 1 spot to start with, this is the value. You would multiply 10 by the A and 1 by the B. But if you switch it around, now B's are in the 10 spot and A's are in the 1 spot. So that would be the value for number 5. And it says that they're equal by if you reverse them, but the one number increases by 9. So that's why I added 9 so that they would be equal. And so those are the 2 equations that I used. I use substitution. So if you want to move that A and then stick in B or vice versa. Yes. Well, okay, so here's where you want to see if you can make sure that by process of elimination, there's only so many digits that will add up to 7. You know, they're either going to be 1 and 6, or they're going to be 2 and 5, or 3 and 4. You know, I mean, there's only so many things that are going to add up to 7. So by process of elimination, we can, but we do want to make sure that we can also come up with the algebraic equations that substantiate what we're doing, because what if they gave us a 3-digit number? Part of the trip, the halfway there, it was half of that, 105, and then coming back was 105, for a total of 210 miles total. So this is the distance there. Distance equals rate times time. So my rate was the boat plus the current. That's the rate times time, 10. And then coming back, the current is pushing against me, just kind of like the wind does for a plane. And so that's why we subtract their rates to get the rate and times time. And these are the 2 equations I used. Now, you could divide off the 10 and the 70. You can distribute it in and then use like substitution or elimination. There's many, many ways to do this problem. If you did it the other way because I misled you and put the 210, don't worry about it. But for now, it should have been half the trip was a 105 and the other half was 105.